just hear someone talking. Maybe they're on mute now, so that's cool. So hi, hello everyone. So I'm glad to have you all here at the hackathon. I think hackathons are really, really fun. And today I'm going to talk about one of my favorite topics, which is how to make web apps, specifically making them in Python. So first, I would love to see in the chat if you all could comment about whether you've done Python before and whether you've done any sort of web development before, whether you've done, front end HTML, CSS, or if you have done some sort of back end development with servers or databases. Would love to just see where everybody is at. If you feel comfortable mentioning in the chat what your experience is with web apps and with Python. I'll just wait a few seconds to see if anybody wants to pop something in the chat. All right. Don't see anything, so I will just guess. So generally, with most GDI workshops, usually people come with a range of experiences from, no experience to having had some sort of experience or professional experience. So, hopefully
Pamela,
there's something for everyone. Yeah.
Hey, so sorry to interrupt you. Again,
No worries.
this is the site that's confusing, but if you are looking at the chat, there's a general chat, and then there's a session chat at the very top. And this is where people are hopefully dropping some of the yeah, I see it. Feedback in here on where they're at. Yeah, sorry about that. That's confusing.
Oh, yay. Okay, beautiful. That was great. All right, so I do see lots of folks who have some Python experience, including the GDI Python workshop. Awesome. All right, great. So yeah, so there should be something for everyone here. And, if at any point it feels like something is intimidating or whatever, that happens when we're learning programming, right? I'm intimidated by stuff every day. And, hopefully we can just help each other learn it. So we'll start off with talking about how the web works, and then specifically how to use Python to develop web servers, and then how to deploy those Python apps so that other people can play with them. So first, how the web works. So just bringing it down to the fundamentals. So on the web is really, the internet is a collection of connected computers all across the world. And these computers can send information to each other in packets. So they're sending packets back and forth over internet protocols like TCP/IP. So they're all sending packets to each other. But then when it comes to the web, in the web, we have clients and we have servers. So a client is a computer that is browsing something on the web, right? So it might be browsing a website. It could even be using an application. So, your smartphone app might actually be utilizing the web. So the client, like your web browser, it navigates to a website. And when it does that, it makes an HTTP request. It makes a request using the HTTP protocol. So it makes a request. That request goes to a server. A server is some computer that's connected on the internet that knows how to service that particular request for that website. So it makes a request to the server. The server says, oh yeah, here you go. Here's that page you wanted. The server sends it back and does that in the form of an HTTP response. So every time that we're browsing the web, we're really sending HTTP requests. So I always like to show the network panel in the browser. So most browsers that you use, you should be able to find a network panel in the developer tools. So you can try going to like tools, developer tools. And then you can pop open a network channel. And I think it's really fun to watch all the network requests go over the wire. So for this page, these are my slides. And actually, let me link these slides because all of you are welcome to follow along with these slides. So these slides are actually a web page. So that means when I load my slides, all of these HTTP requests go to the server that's hosting the slides in order to make these slides happen. So it actually makes 29 requests. One of those is the actual HTML page, but there's a bunch of JavaScript that it loads. There's a bunch of CSS that it loads. There's custom fonts that it loads. There's lots of images, super, really cute images that it loads. So these are all the requests that it needs in order to make this web page. And 29 requests sounds like a lot, but actually a lot of modern websites make way more than 29 requests. Like, so Go Fug Yourself, which is a blog that I should stop reading at some point, but it makes a huge number of requests. So we see here 136 requests in order to load the page. And that's because this is a web page that's very heavy in images and ads and JavaScript and all that. So all of these are HTTP requests. For each of them, there's a status code. So every response has a status code. Now, if a response was successful, you get an HTTP 200. If it wasn't successful, then you can get any number of other HTTP status codes. So let me look at HTTP status cats. This is my favorite way of showing the status codes. These are great. So these are a bunch of codes. The most familiar code is 404, not found. And there's a cat that's not found. But these are all possible status codes that your server could respond with. So 400 generally means something like the user typed in a wrong URL or didn't use the right authorization. 300, these are all kind of redirects. So if something's redirecting to a new URL, usually the server sends a 300. And then 500 means something really bad happened. So you really don't want your server to be sending back a 500. It usually means it had an error, the kind of error that you don't want it to have. So we really don't like 500s. Okay, so there we go. So that's the web. The browsers send requests and the servers send back responses with status codes and the content. And here we can see this is what it actually looks like. It's actually a kind of a plain text protocol. So you can see the HTTP request says, I want to get this page using this protocol and this version of the protocol. And I want to get this page at this domain. So it says this is what's hosting the page. So it tries to find the server that's responsible for www.example.com. And then once it finds that server, then that server will look for this path and figure out how to give back the content for it. And once it does that, then it sends back the response, which has the protocol, then the status code, and okay if it was successful. And then it'll have headers, which describe the response. And then it'll have the actual response body. So this is an HTML page, so the response body is HTML, but it might also send back CSS or JavaScript or an image. Anything that you could serve on the web, you could serve back here. So that is HTTP. If you at any point you have questions, do feel free to put them in the chat. I will try to look at the chat from time to time. So if anything's unclear about HTTP, I'll just pause now to see. Because basically we need to understand this in order to be able to write a web app, because web apps are built on top of the HTTP protocol. All right, lots of love for HTTP cats. That's right. There is also HTTP dogs. I'm not a dog person, but that's your thing. You can check out HTTP dogs. So web pages. So that's what we're going to be making a lot of. They're made up of 3 languages generally. So they have to be made up of HTML. That's the core language that defines the content and uses tags to define each parts of the content. CSS for styling. So most people add CSS, otherwise your web page can look quite plain. But hey, if you're into that, there's even a naked CSS day every year where you just strip the CSS off your web page, and that bring it back and make it retro. But most people like to have CSS on their page, make it look pretty. And then JavaScript is what we use to make pages interactive. You don't have to have JavaScript on your page. You can have very functional websites without JavaScript, but quite a few people do use JavaScript in order to make things happen on the page without having to reload it. Okay, so what does a server do? It depends. Some servers can be very simple. So the simplest server just has a bunch of files on it and serves up the files. It says, oh, you want this HTML page? Here it is. I already had it just, in my file system. But most people will write more sophisticated servers that actually do some sort of processing, right? So they don't just spit back HTML. They check to see like, oh, is the user logged in right now? Do I need to grab some data? Do I need to do some sort of security checking? Most servers will do, will do this additional amount of processing. So the times you really need a server that has these capabilities, if you want to have a website where users could log on to that, then you definitely need to have some server-side processing. If you want to have a website that has a database and you fetch data from the database, then you're going to need some server-side code for that. So that's where you start to get into fancier server code. Okay, so now let's see how to do it in Python. So we're going to start with the simplest, which is the HTTP module. This is built into the Python standard library. So you can use this for really basic servers, but see this big warning up here. It says it's not recommended for production because it only has really basic security checks, and a legit server has much better security checks than this. So this server is still really useful when you're doing local development. I use it all the time for local development, but would never use it on an actual server. But I'll show you, so for, so these slides are written in HTML, CSS. So they're just files. So I could actually run a local server. Let me make this bigger. Okay, so I can run a local server just using the built-in HTTP module, and I'm going to tell it what port to run on. So every server runs on a particular port. Every server has a bunch of ports. Like imagine ports in a bay or a dock, like the San Francisco Bay. Every server has a bunch of different ports, and you kind of agree on what port you're communicating with, and that's just part of how servers communicate with each other. So I'm going to say I'm starting a server on port 8080, and it's just going to serve up the files in this directory. So then I'm going to visit it in here. Okay, and here you can see it's just serving this up like a file system. So we can see what's in here. We can see here's the slides I'm currently working on. So when I'm doing local development of just basic files, then I can use this built-in server here. So that's useful, but not really that useful once we want to actually make a server to put on the web that other people can use. But it is helpful to see what it is that makes up a server. So I also have this very simple dynamic server, which uses the HTTP module. And I'll show you what it looks like here. Let me do raw. Okay, so this is using the HTTP module, and it uses these classes HTTP server. So this is an object-oriented way of writing a server. If you've done object-oriented programming in Python, you can see a class that inherits from this base request handler. And this class has methods that it overrides. So we override a do-get method, and this is what's going to process all the get requests. So with the HTTP protocol, there are different verbs. So the standard verb is get. So whenever, when I loaded my web page here, I was doing a bunch of get requests. I was just getting the information from a server. But you could also do other verbs like post. When you're filling out a form, you're doing a post request. You're posting information to the server. And there's a few other verbs as well, but the most common ones you're going to be dealing with are get, to get the data down, and post, to send the data, which is typical with form submission. So here we can override do get, and we say, okay, this is what you're going to do when you get a get request. It just writes out what it got. This is a very boring server, incredibly boring. And then when you get a post request, it's going to write out the post data that I got. And then I can run this server on the port. So so that's a really, really basic server. I'll run it, but it's so basic that I almost don't want to show it, but it's nice to build up, complexity here. So CD, Python, simple server. Okay. Python 3 server.py. Oh, an address is already in use. That's right, because I already started running this actually in another terminal. So I'm going to kill that other process. Let me make this much bigger. Okay. Let me try running this again. All right. We can see it's running. Okay. And this just spits back whatever we give it. So we say we want a get request for, index.html, and it just gives it back. So the point we're trying to show here is that we are dynamically creating responses. The previous example, we were just spitting back files that already existed, but here we're actually dynamically writing back responses, right? So here I said, hi DDI, and then we see it. So this is building up to the ability to have servers that can spit back pages that get dynamically created based off of content. But let's move to something more exciting than that. So most people are going to use a framework that is actually legit and has good security checks in it, since we shouldn't be using the HP module in production. So the two most popular frameworks are Flask and Django. Has anybody used Flask or Django? You put in the chat. I think at least one person. Oh yeah, Tina says, and Brianna's used Flask. Okay. And Tina said that they use Flask too. Mara's learning Django. Alexandria is learning Flask. Okay, cool. So Django. Okay, great. We have a mix. So I've used both, and they both have different things that they're good for. Flask is more lightweight. It's less opinionated, which means you can take it in a lot of directions, and it's not going to fight with you that much. Django is much more opinionated, and we'll see that it does make some things a lot easier. So there's lots of apps that are in production that are written in Flask. Khan Academy was originally written in Flask. They did recently port it over from Flask to a whole other language, Go. So from Python Flask to Go and a custom framework. Reddit is still written in Flask, as far as I know, and so is Netflix. So these are production apps that are written in Flask. And yeah, so it actually does work, and it's a fun framework. So let's look at a simple Flask website here. Okay, so this one's a very basic one. Welcome to your first Flask website. If I click on About This app, it's actually a 404 page, and it does have a picture of a cat. So you can see we have an index page, and we have a 404 page. We don't have much else. But let's take a look at the code for that. So here, we can see that in this code, we import the Flask framework and a few things from the Flask framework. We create a new Flask app, and we tell it where our templates are. And then we define the routes. So here we've got 3 different routes. The first one is our index page. That's the one that we see here. And we say we use a decorator. This is what's called a decorator in Python, is when you have this at and then and then something before the function. So this is a decorator. So we say at app.route, and we say what the path is going to be. So we're decorating this function and saying this function is going to handle this route. And then this function returns back the template index.html, or a rendering of that template. So a lot of times when you are doing web development, you use templates so that you don't have to have a bunch of HTML in your code, because having a bunch of HTML code in your code is gross. I did it down here in the 404 handler just to show you how gross it is, but it's really not nice to have a bunch of HTML in your Python. It might seem okay at first, but this is like not even valid HTML. Like it doesn't have all the, all the stuff it should have to be a proper HTML page. So it's just really not nice to have this in our Python. So we'd much rather put our HTML in actual HTML files and use templates to handle them. So if we look at index.html, we can see that this is just an HTML page. So there's nothing fancy going on here, just an HTML page. Now let's take a look at the next route because it's more interesting. So there's this other route which responds to the path hello, and it renders the hello.html template, and it passes in a variable. And this is how we very commonly use templates, is that we bring in variables to the template and we combine the variables with the template in order to customize how that template comes out. So if we take a look at hello.html, we can see it actually has some embedded code here. This is called the Jinja templating system, and this is the Jinja syntax. So this is a custom syntax that's for Jinja templating, and so you have to learn a whole other language, but it's very similar to Python and other languages. So this is saying if the name variable exists, it says hello to name. Otherwise, it says, oh, you're anonymous. So let's actually try going to this path here. So I'm going to say hello. And if I don't pass in a name, then it says, anonymous. Otherwise, I'm going to say hello to myself. And here we go. And so all of you can try this too. And so then you start to see this is what's powerful about server-side processing is that we can customize the page, based on some information. So here we're customizing it based on query parameters, but we could also customize it based on who is currently logged in by looking at their cookies and by setting up a whole user system. We could customize it based off of the geolocation of the IP of who's visiting it, or based on the browser that they're using. There's lots of ways that we can customize how a site looks. So there we go. And then finally, this one is an error handler. So this one responds to any 404. So anything I write after here that it doesn't understand is going to get the cat. But that's something nice with Flask too, is that you can override the error handler so you can have your own special 404 pages that are, fun and maybe give the user more information. So this is a very basic Flask app here. Let's see. Yeah, so Jennifer had a question about why use Django over Python. So I'll definitely touch on that when we get to Django, because I think we'll be able to see the difference more easily when we get to it. It's a great question. Okay, so we actually have an exercise. So the goal is to actually do some exercises, like see if y'all can get some of these apps running. So here is the repo. So I have set up this repository so it works with this new thing called GitHub Codespaces, where it's going to open entirely in the browser, which is really cool because then you don't have to do all the setup that you normally have to do locally with managing Python versions and installing and getting everything working. You can also check this out locally too if you want to try it, but I really like Codespaces. So the way to do Codespaces, let me delete my current one so I can show from scratch. Okay, so here, when I look at this repo, and let me paste this as well. So when I look at this repo, I click on code and I say create code space on main. And now it's going to set up the code space. When it sets it up, this does take a few minutes because it's literally like building basically a virtual machine in order to create a development environment for this project. So this takes a little bit of time the first time you set up a code space for a project, but then once it's set up, it's quite quick. So I actually do most of my development inside code spaces right now because I hate dealing with getting everything working locally. I don't like it. So I just like to use code spaces for everything. So Jay asked, is Python a good path for beginners? Any advice for folks like me trying to enter a new career field? Yeah, so that's a good question. Python is generally considered to be a good path for beginners. It's still going to be hard. So I usually actually recommend starting with HTML, CSS, which is a more declarative language, and then getting into general purpose programming with Python. But a lot of people do get started with Python, and especially a lot of people get started with Python for data analysis. So there's lots of data analysis and analysts who get tired of using Excel and spreadsheets, and then move to Python in order to do more powerful things. So I think in terms of what path you take, I would say it depends on what you're into and what your current skills are. What's really nice is to figure out what your current skills are and to combine, find a way to bring those current skills in. So like my partner, he started off in geography and was doing lots of, spreadsheets and analysis with GIS tools. And then he learned programming in order to be able to do that faster. And now he, does software engineering for DoorDash, and he works on their geographic tools. And it's a perfect fit for him. So he's figured out a way to bring in his previous skills into programming, and that made the path better for him. So if you can find overlaps between your current skills and interests and programming, I think that's always a really nice thing if you can find that overlap, or at least you try and find the path that works best for you, whether you're into front end development or into back end development. There's so many different programming paths, so it's hard to say what's best for everyone, because it is going to depend on you. So some questions on code spaces. Where would the code space I start be located? Oh yeah, so that's a good question. So it creates a code space based on my repo, but then when you try to make a commit, it'll actually auto detect that you don't have a fork yet, and it'll make a fork for you, which I think is a really cool little thing. So you could formally make a fork first, and then make make the code space based on the fork. But last I checked, it'll actually auto detect and then offer to make a fork when you do a commit, which is really cool. And we could test if that actually really works. But I think that's what it's been doing for me. Right. And Tina asked the same, will a copy of the project be in your own repo? So what it'll say is, let me show you my code spaces. And GitHub just announced last week that code spaces it's like 60 hours per month were free for everyone. So where are my code spaces? My code spaces. Oh, there, up there. So it'll list my code spaces, and it says which of them I have uncommitted changes. So even if I haven't made a fork, it says if I have uncommitted changes. So if you forgot to commit things, but you did make changes in a code space opened on my repo, then you hopefully could just check here and see that you had uncommitted changes. So every so often I'll check here and see if there's something I forgot to commit. Most of mine are no changes. Okay, so let's see. I think it started. Where even are we? Okay, here we go. All right. So it opened up. Make this bigger and bigger and bigger. Okay. So here it is in the code spaces. And you can also do this locally if you want. I just love it. So we can run the repository and code spaces. Oh, it did already install the requirements. So if you were doing this outside of the code bases, you'd want to install requirements. I have configured the code space to already install it, but if for some reason it hadn't, you could just tell it to install the requirements. This is a standard way that anytime you're in a project, the project should declare its requirements in a requirements.txt file. And then you can do pip install -r requirements.txt, and it'll install those requirements. There's only one requirement for this project, so it's pretty fast. Okay, so then, okay, so I told it to run the server. So I python app.py, that should run the server because of this code here. It should run it on port 8080. And then CodeSpace actually says, oh, look, there's an application running on port 8080. Do you want to open in browser? So I'll click that. And there we go. So this is the same thing as viewing localhost. So for those of you who are used to developing locally, and if you have done web development locally, you'd probably view it at localhost 8080. Since we're now in a browser and we're on a machine that's in the GitHub cloud somewhere, it's not going to show localhost anymore, but this is the equivalent of localhost just on a GitHub machine. So it'll actually, I think it'll even live update if we make changes. Let me see. Does it update? Let's try. Here we go. So we can make changes to our files and then reload and then see the changes. So we can actually do our full local development cycle here in Codespaces. So I'm hoping it actually works, but if that doesn't work for anyone, just let me know, because I file lots of bugs with the Codespaces and VSCode team. So I'm always happy to find out what isn't working. Yeah, let's see. It worked for you. Cool. Okay. Oh yeah, and to clarify, I do work for Microsoft now. I recently started working for Microsoft, and Microsoft owns GitHub, so I have a more direct connection to the GitHub team, hopefully. Okay, so this is the goal, is to see if you're able to get the app running either on Codespaces or on your local machine. And then these are things I suggested that you could try doing. So you could try adding a new route for about, since there isn't a route for about right now, and we're getting that 404. And then I don't know if anyone will have time for this, but you could use template inheritance to refactor the templates to all use a base template instead, which is a nice thing to do. But I think it'd be pretty cool if even anyone's able to add a new route. So 11:38 right now. So let's go try this for 8 minutes and see what you're able to get going in 8 minutes. And you can also use this for a bio break or a bathroom or whatever. And I will sit here and see what questions there are. Actually, I need to get water, so I'm going to get water. I encourage all of you to get water. It's a good thing to drink water, and then I'll be back. Okay, let me know if you have any questions. Oh, okay. I realized that maybe this was only really enough time to get the code space loaded and the server running, but it looks like there's some thumbs up for people who managed to do that and get it running. Did anyone actually manage to add a new route or make any code changes? Oh, I'm seeing more thumbs. Okay, so when you have time later, if you want a challenge, you can try to do the other steps for this exercise. I never expect us to actually get through all this stuff because we have a pretty short time today, but I like to give ideas for people who want to challenge themselves later. Oh, wow, Brianna, nice. Were you one of the ones? Yeah, you've used Flask. Nice. Very cool. So you can help others who are wondering how to do that later. Oh, Murtaza. Nice. All right. Well done. So those of you who did manage to get that, if people in the Slack are, working on some Flask stuff later, you can help out. If you all decide to use Flask for your hack, then you've got some folks to ask questions. You can also ask me questions. Nice. Okay. Well, now I'm going to interrupt all your hard work so that we can talk about adding databases, because that's where things get really fancy. So web apps very often are going to use a database. We need a database every time we need some central source of information that's going to be accessible across multiple users and computers. If you only need to have it on a single laptop, then you can store it in the browser in local storage. But most people want to be able to log into a website from any computer, from their phone, from their Chrome, from their Safari. They want to be able to log in from any computer and be able to see the same data. So it's very common to use databases to store user data. It's also common to use databases to store just global data. So you can imagine like a news website, they're probably going to use a database to store the articles, right? So most websites that are at all sophisticated are going to be using a database. So we have a Flask example that uses a database, and this is actually a Python quiz. So all of you can take this quiz now. So you just randomly pick your answers. I'm trying not to give away the answers here, and then submit the score, and then I'm going to reload and see if we get some high scores here. Okay, I'll show the code and then I'll check back to see what scores people get. So once again, we have pretty much all the code in app.py, but we do have a lot more going on. So if we look at the requirements.txt, you see we have a lot more requirements. So now not only do we have Flask, we have all these things to deal with databases. So we have Flask Migrate, Flask SQL Alchemy, SQL Alchemy. So basically there's this package called SQL Alchemy. That's a way that you can use from any Python app in order to interact with a database, with a SQL database, which is what we'll be using. And then we'll also have this package PsychoPG, which is for Postgres. So we're going to be using a PostgreSQL database. So this is a variety of SQL. So there's a bunch of databases for relational data where tables are related to each other, and there's SQL databases. There's different flavors. A popular flavor is MySQL. So you might have seen that before. There's also Maria SQL, I think. There's SQLite, which is also popular, but we're going to be using Postgres or PostgreSQL, which is very popular with the Python community, and it's a very powerful SQL database. So that's what this package here is for. But SQL Alchemy you can use to interact with any kind of SQL database. So we have all these requirements, a lot more requirements, and then in our app.py, we're going to be importing a bunch of things from those packages. So this time, we've got a lot more code to configure the database, because we need to tell our app how to interact with the database. And we also want our app to be able to work locally as well as when it's deployed. So that's why there's a lot of code here in order to be able to have settings that work locally versus deployed, because it's going to be different. So here you can see we tell the app what the database URI is. So it knows how to communicate with the database. And then we create a database object, a DB object, and we connect it to the app. And then we define the models. So we define the models using object-oriented programming. So by making classes, and these classes inherit from this base class db.model. And you can hear we say what the table name is going to be. So this is going to be the actual table in the SQL database, because we don't usually like to do capital letters in SQL names. So we tell it what the table name is. Then we say what the columns are going to be. So this table is going to have ID, player, and score. So ID is an integer, player is a string, and score is an integer. So I'm just keeping track of what scores each of you get. Okay, so that's setting up our database, setting up the table in the database. This database only has one table. If you haven't worked with databases before, you can think of it like a spreadsheet that has one worksheet, and it has, a header row with ID, player, score, and then we're going to be adding rows to that. So here, this is the same thing we had before with the index, but then we have a route that we use when you submit your score, and this one is responding to HB post requests, right? Because I said when we submit forms, we usually are going to use a post. So this route only responds to post requests, and when it gets the data, it creates a new row in the database, and it does this by initializing a new player score object. And it gets the information that got submitted in the form, and it adds it to the database, commits it to the database, and returns OK. And then we have another route here that gets the scores, and this one does a select. If you know SQL, it's doing a select. It's just using this funky way of doing a select in, using the SQL alchemy function. So db.select, that's the same thing as a select, a SQL select statement, and then it returns the results as JSON. Okay, so I realize now there's a lot going on here, and you may have varying experience with SQL, JSON, etc. But yeah, quite a bit in this one file that you can wrap your head around. So yeah, and if anyone has any particular follow-up questions on that, I know there's a lot going on there. So let's see if we have any. Oh, there we go. Thank you, everyone. So we can see that we have some scores of 100. Very nice. But it's all about growth mindset. You can take the quiz again and get higher, because I don't have much security on this quiz. So you can all, just keep taking it and just keep upping that score. So that's one thing that you might want to add to an app like this, is to actually, maybe have people log in and tie their score to their user ID, or maybe you only allow one score per IP address. There's all sorts of, things you can come up with, improvements you can come up with in order to make this score handling more legit, because this is a very easy thing to game. But that's what's fun about websites, is that users like to break you, and then you figure out how to not let them break you. Okay, so there we go. So that is how you make a quiz in Flask. But here's the thing, is that Flask is kind of a pain to use the databases. I just walked through all that code, and it was kind of hairy code. I think it was pretty hairy. I actually found it pretty hard to write that code, because normally when I want to use a database with a Python application, I use Django. Django is a really good framework if you're going to have a database-heavy app. It's got a really nice way of interacting with databases and tables. It's just got so much stuff built in for that. So, the question earlier about, when would you use Django? If you're going to have a lot of database interaction, and then it has just a lot of nice features for it, and we'll see those features. So apps written in Django. Coursera, when I first joined Coursera, it was written in Django. It did later get ported to Scala and Play, but I quit as soon as they started porting it, because I preferred Django. Instagram, I think, is still written in Django. Pinterest was originally written in Django, and then they moved to Flask, which is interesting. I think they decided Django was too opinionated for them, and they needed the freedom of Flask. And I think Eventbrite is still written in Django. And Django was originally built for a news website. So, it definitely is very usable for news websites. So here we have a Django quiz. So this one works a little differently. So y'all can try this one out. I'll also just do this one together. So this quiz has different types of questions. This is a free text response. So what plant do monarch caterpillars eat? They eat milkweed. And then which of these plants are a host plant for swallowtail caterpillars? Dill is one of the host plants. And then what do butterflies form while pupating? They form a chrysalis, not a cocoon, because that's what moths form. And what song from Encanto should have won an Oscar? I don't know what happened. Dos Oruguitas. Okay. And then finally this one. Okay, so those are all the quizzes. So this is a very different kind of quiz. But the thing I want to show you is that this comes all with this beautiful way of administering the models. So let me get the code space started for this one. Okay, so this code space I already had loaded because I must have been working on it recently. So this is going to be a little faster to load. So let's take a look at some of the files while that's loading. So Django is built around the idea that you're going to have data and that you want views, you want pages to be built based off that data. So every Django app has a particular format where you have a models.py, a urls.py, and a views.py. So we can look at them in various orders. Let's start with models.py. So here we are using the models that are built into Django. So this time we didn't have to bring in SQL Alchemy because this is all built into Django, and this is what's really nice about Django. So here we have all these classes that inherit from the model class in Django, and you can see that they also define their columns. So a quiz has a name, that's all it has. A question has a quiz that it's related to. So these two things are related to each other. So every question knows what quiz it's a part of, and it also has a prompt. An answer is related to a question. So this is all about relational data. So I don't know how many of you have dealt with relational databases before, but one of the things you do is try and figure out how things are related to each other, and then you model that in the code. So here we say that, okay, an answer is related to a question. Right, so every question has a particular answer associated with it, and there's a correct answer. And then we have two different types of answers: a free text answer and a multiple choice answer. So this data here is a bit more complicated than the other data we looked at because there's a lot of relations going on here. So here we have the models. Then we'll show the URLs because that'll be shorter. So these are all the URLs that our application responds to. So it responds to the index URL, which is just nothing after the root. It also responds to just having an integer, and that'll display a quiz for that integer. It can display a particular question, and it can also grade a question. So these are all the URLs that are defined for this Django app. And then we have the views, and in the views, Django has this idea that views are related to models, and they try to make it really easy to make a view for a model. So the index view is based off the quiz model. And when we say this, Django will automatically pass in all of the quizzes to this view and make it easy to make a list of them, because we've said we want this to be a list view. So this then means in our template, we can iterate through the quizzes that get passed in. So Django is passing in this quiz list. It's doing all of that for us because all we had to do was say, hey, I want a list view for quizzes. So when we said that, Django said, okay, I'm going to pass you the quizzes as a list, and you can do what you want with them. So this is what's really nice about Django is that, if you think you're going to have a lot of data and you think you want to, you're going to have some pages where you have lists of each of the types of data, and then other pages are showing, just one row. It just works really well with Django. Okay, but it gets cooler. So let's see. Okay, so here I am in here. And I already did the other steps. So I'm going to just run server and see if I can log in. Okay, so when I go to the website, I actually do get an error. And that's because I actually don't have anything defined for the very index of the web page. I need to go to /quizzes. So Django also divides websites into apps. So this website has a quizzes app inside of it. So this is how Django makes things more modular. So then it's easy for you to bring in apps from other places. So here we're going to the quizzes app, and this has all the code that I just showed underneath it. So the /quizzes gives us the index page here, and this is the quiz list. And then we can click on this, and that loads in the questions. Now, the cool thing is we can go to /admin. This is the Django admin. This is what's really cool about Django, is that it knows you want to deal with databases. It knows it's a pain to administer databases. So it creates this admin for you that makes it easy to create the types of data that you have. And it automatically creates all of this. I didn't do any work for this. So I can add more questions to my quiz. So this one doesn't have many yet because this is my local version. What does a swallowtail caterpillar eat? So I'm going to say dill, save. Okay, and so and we can edit existing ones. And this is the really cool thing about Django. So I don't know if I've sold you on Django yet, but there's a lot of really cool aspects. Yeah, Tina's sold. Great. I'll get my Django commission now. So when you are dealing with Django, there are a few steps you need to do, and these are all in the README here. So first we install the requirements, then we run the migrations. So this is something you have to do actually also for the Flask app. So running the migrations is actually telling the local database what tables it needs to make, right? Because if you've never set up the database before, it needs to make those tables for the first time. So you're always going to want to do that when you first set up the server, and then you can run the server. And then to use the admin, you do need to do this step to create a super user because it needs to know what credentials to log in with, right? And it actually wants those credentials to be pretty secure, and it actually gives you a bunch of error messages if they're not secure enough. They're like, no, that's not good enough. Come up with a better password. So you have to do this step, and then remember your credentials, and then you can log into admin and start doing stuff. So really cool. Okay, so I think we're going to try and see if you all are able to get this running. So same thing as before. I set this up in CodeSpaces. Even this morning, I was working on it, trying to get it working really well in CodeSpaces. So hopefully it's working well now. So try to get it running either in CodeSpaces or locally. And then see if you can create a super user and get into that Django admin. Because when you get your app running, there's going to be no questions and no quizzes because it doesn't start off with any data. Like I don't have any starting data. So see if you can create a super user and get to the admin. And if so, add some data, at least one quiz and one question in that quiz. And then, this is really extra here, but if you want a challenge, you can try to add a new route that shows a list of all the questions. Okay, so let's go till 12:15 on that. And then when we come back, we will talk about deploying these apps and actually hosting them for people to be able to check out. But yeah, let's do this for 10 minutes, and I will be just here waiting to see if there's any questions and just cheering you on. Woo! All right. Welcome back, everyone. I see a couple people managed to get it running. Yeah, so I was saying that the setup once you start dealing with databases is a lot harder. And so hopefully you can get it running in code spaces. If not, you can try to do it locally, but locally then you have to download the PostgreSQL application for your computer, whether that's Windows or Mac. And I actually think I found it really annoying to set up Postgres locally on my Mac. So I'm quite happy to just write it in CodeSpace instead. But whatever works for you. I do actually, now that I have it running, here is the it's really large, the Postgres app, which the font size is super huge right now, but it is possible to have like your local database set up as well. So whatever works for your flow. All right, so now for our final topic. And something I want to say with Django. Okay, so yeah, there's a lot to understand about Django. So one thing I would recommend is that if you are trying to wrap your head around Django, my explanation was much too fast and not thorough at all. So what you can do is the tutorial. This is the starter tutorial. It's like a 7-part tutorial, so it does help to have a few hours or more set aside for it. But it will go through the whole step of creating a poll application. So pretty similar to the quiz application, but it goes through it step by step. So if you do really want to wrap your head around Django and you have some time, I do recommend this tutorial. I mean, even if you're not able to do it for a few weeks, I did it a few weeks ago and, it helped me remember some stuff, and I've used Django for years. So I do recommend that tutorial in order to get deeper into Django. Okay, so now in our final minutes together, we're going to talk about how to host web apps. Now, as I mentioned, I do work for Microsoft now, and I specifically work on Azure, which is Microsoft's cloud computing offering. So I am going to be talking about Azure as the hosting option. However, a lot of what I'm saying is applicable to other cloud computing providers. A lot of us have similar offerings, so you can find similar things at Google or AWS. But since I work at Azure, I'm going to talk about Azure. So we need a way to host our website on a server. Now you might say like, oh, what about code spaces? We just saw that CodeSpace makes this, made a URL for when we were developing on something, but that URL is ephemeral. Yeah, it's ephemeral. So it's only running as long as we've got the code space running, and as long as we've got that command running. And by default, it's not even visible to anyone other than us, the logged in user. So that's not really hosting the app. When we want to host the app, we want to put it on some server that's always available, right? That could always respond to requests, that has some amount of reliability to it and is actually designed to receive a lot of traffic, right? So there are many possible ways to host a app. So a common thing is to just rent a computer in a data center. So you say like, oh, I just want to rent a server in a data center. Related to that is renting a virtual machine. So that's basically renting out a part of a computer in a data center. So maybe you don't need the power of the whole computer. Maybe you just need part of that. So you're basically renting a virtual machine or renting several virtual machines put together. And then there's also what we call platform as a service. So a platform as a service is basically renting a virtual machine, but it's more higher level, so it does more things for you. So a platform as a service may also do like load balancing, auto scaling. So if it sees that if you're getting more traffic, it could spin up more virtual machines in order to serve your application. So a lot of people do go for using platforms as a service these days. Because it does do some of these things for you that you don't want to deal with. But here's the things you need to consider is just how much control do you want, right? If you want, full control, then you got to build your own data center, right? You also need to consider like how much do you enjoy administering systems? Do you like dealing with computers that are, being hammered by lots of traffic, right? Do you like sysadmin? If you do, then great. But if you don't, I don't, then you might prefer using a platform as a service. And then how much do you need it to scale, right? So if you do need to be able to scale to arbitrarily large amounts of traffic, then you need to keep that in mind. And then also, what's your budget? That's a big question too. So, if you don't have much of a budget, it's good to host somewhere that's free or nearly free. So here are some of the hosting options on Azure. As I was saying, these are pretty similar to hosting options in other places as well. And this kind of a spectrum of ways of hosting. So, Azure is a cloud, right? So AWS is a cloud, Google is a cloud, right? So we have the Azure cloud, which is really the Microsoft data center. So Microsoft has data centers all over the world that are able to serve people's web applications. And then on top of that, Azure has offerings that you can use to host. So some of those offerings are specifically around containers. So containers means Docker. I don't know how many of you have gotten into Docker, but a lot of people are using Docker these days in order to package up applications and make it so that they run everywhere. So a code space is actually just a Docker container. So all of those times you open a code space, it was actually creating a Docker container. So Docker is a popular way of being able to run something anywhere by specifying, here's everything that belongs in this Docker container. Here's all the, the requirements, the packages, and here's what you need in order to be able to run this anywhere. So if you do want to be able to just, deploy a Docker container to the cloud, you could use Azure's Kubernetes service or Azure Container Apps, which does a little more hand-holding for you, does more stuff for you. But then even higher level than that is the platform as a service offerings. So there's Azure App Service, and then there's Azure Functions, which is also known as a serverless technology. So basically, there's a lot of options here. For Flask or Django, I would tend to go for Azure App Service. That's designed to be the highest level offering to deal the most with stuff for you. And it has specific handling for Flask and Django apps. It actually knows about Flask. It knows about Django because we know that people are, writing apps in those. So we try to make it easier to run Flask and Django apps. So that's what I recommend, and that's what I'm going to show here. And all these demos that we saw, these are all running on Azure App Service. You can see it in the URL here. It says App Service. Now, besides just the app service, when you do deploy something into a cloud, a lot of times you need to add on additional services. So in this case, we're going to need a database. So we can add on an Azure Postgres database. We might need some storage for files, so we could add on some storage. We might need to set up some networking, and we actually do when we're making a database because we want to have our database and our app within the same virtual network so that only they can talk to each other and so that other people can't talk to our database that we don't want to talk to our database, right? So we're going to add in some networking too. And there's other stuff you might want as well. So these days, when you use cloud providers, a lot of times you're actually mixing and matching things from their different offerings because there's so many different ways to make an app. So a little overwhelming, but we try to make it easier by having templates. So for the Flask quiz, the way that I host it on Azure, these are the things I use. I use an app service with an app service plan, which just says how it should scale, and then a PostgreSQL database. And then I have this workspace just that tracks analytics. And the way that I deploy it is I use this new thing called the Azure Developer CLI, which is, to me, the easiest way to deploy. And I just run this command azd up. So let me actually, instead of trying to show that live, I actually have a video where I do it. So let me just open that video. You can see my taste in YouTube. There's it go. Okay, so let me just show. So azd up, you can run this in code spaces or locally. So first it has you log in because it needs to know, which is your account you're going to get logged into. So we do the little login thing. And we also specify an environment name, and this just becomes a prefix for everything that gets created in your Azure portal. And then we selected Azure subscription. That's like just a billing account in your thing, but you can have a free subscription for this. And then at location, so these are the data centers. Remember, there's data centers all over for Azure, and so you need to specify which one you want. You typically do one that's close to you. And then it starts figuring out how to deploy this app. And the way it knows how to deploy this app is because I wrote all these infra files, and I wrote them using this language called Bicep. It's a lot like Terraform, if you've heard of Terraform. So it's just a declarative way of declaring what cloud resources we're deploying to. So we have this main.bicep that creates a resource group. This is just like a folder of everything we're making. And then we have resources.bicep, which creates all the other things we need. So it creates a virtual network. It creates the website, the app service. It creates the Postgres server. So I've already written this, for these Django and Flask apps, so that all you should have to do is just run AZD up. So when you run AZD up, it looks at all those files and says, okay, this is what I need to make. I see what account you're logged into. I'm going to start making them. So you can see it makes all these things here, and it can take a little bit of time. So we'll just fast forward. Okay. So then it's created it all, and then it actually needs to deploy the code. So that's where it takes all the code that you have and uploads it to the Azure servers so that it can serve that code from their servers. And then it's deployed. So that's the AZD up process. And I'll log into the portal to show you what gets made. So for like the Django, or here's the simple Flask DB quiz. So here you can see this is everything that gets made. So we have the Postgres server, app service, service plan, all of that. So I can also interact within the portal. But for me, the easiest way to deploy is just to do that AZD up command. Okay, so that's the Flask quiz. Oh, so the Flask quiz, I didn't do it as fancy. The Django quiz, that app I added in the VNet to show how you could do that. I did protect the database in the Flask quiz using just using IP protection. So it's only Azure services are allowed to communicate with it. But if you really want to up the level of protection, then you add the VNet like I did here. So the final exercise is deploying an app, but we're at 12:28 right now. So I don't think we'll get to that. But I'm always happy to answer any questions about it, because this is what I do all day. I just spend all day deploying. It's kind of a strange life. But I think it is really fun when you actually get something out there on the web and it's working, and you get to share it, and you get to, share your quizzes with people. And I just saw the different ideas that people have for this health hackathon. So I love the theme of the hackathon. Really cool. Very excited to see what all of you end up coming up with. And I see lots of fun things mentioned in the Slack. So here's some more resources. We have a Discord, but yeah, if you do deploy to Azure and you have any questions, feel free to tweet at me. I'll just put all my different contacts. So I've got Twitter, I've got Mastodon, I've got a Microsoft address. We have a Discord, if you like Discord. So lots of different ways of getting in touch. I'll also try to look at the Slack, but there's a lot going on there. So yeah, I'd be happy to help anyone with Azure questions. So now we're at 12:30. Is there any last questions that I can answer now? We covered a lot. And if any of you are looking for like an example app that does something in particular, I don't know, sometimes I can dig those sorts of things up. I saw there's people like doing scraping. So Beautiful Soup is really great for that. I have a lot of Beautiful Soup projects. So, whatever it is you're working on. All right. Well, hopefully you know where to find me. Thank you everyone for participating. Oh yeah, so Murtaza asks, are there any tools that make it easy to have inline code on Django apps? Depends what you mean by inline code, Murtaza. Like leak code, code boxes. Oh, okay. Yeah, great question. So with Django, there's lots of like, Django has a big ecosystem. So you could look to see if somebody's already written an app for displaying something like leak code, right? So there's like Django, I don't know the leak exactly right now, but because Django is designed for modularity, you can look to see what apps other people have already written, and then it could be really easy to bring in. So I can search for that in particular to see if anybody's already written that. Um, but if not, then you can make like a widget that would make it easy to map a particular DB model to a leak code field. So but I'm happy to look afterwards to see if that sort of app already exists. So that's the cool thing about the modularity of Django and the Django ecosystem, that it's possible that somebody has already written it, and then you'd just be able to bring that folder into your app that has the models and views already defined, which is really cool.
Hey, Pamela, it's Katie. Just want to jump in, say goodbye. I know you're going to hang up. Thank you so much for this. It was super helpful.
Yay. All right. Good luck on the hackathon. And I'll have another workshop tomorrow about making
we'll see
APIs.
you tomorrow. Thanks, Pamela. Have a great day.
Bye.